Hey guys, Mr. Backerberg here. In this video, we're going to look at the area connection. So we've seen that a definite integral can be interpreted as the net area between the graph of our function and the x-axis. So if we've got a chunk of our graph that's above the x-axis, then that contributes positive area. But if we've got a chunk of our graph below the x-axis, then that contributes negative area. But we have to be careful to distinguish what type of area it is that we're talking about. If we are talking about net area, then like I said, if you're above the x-axis, it contributes positive area, and if you're below the x-axis, it's negative area. But we can also find the total area underneath a curve between the curve itself and the x-axis. So in this example, we're actually going to find both types of area. We're going to find the net area first, and then we'll find the total area second. So we've got the equation 4 minus x squared, and we're going to look specifically between x values of 0 and 3. So I'm going to scroll down a little bit so that we can see all of our picture. Now, as we can see, going from that x value of 0 until we hit that x value of 2, that portion of the graph is above the x-axis, so that's going to contribute a positive area. So I'm going to write out an integral that's going to help me find that area. So this is going to be the integral of our 4 minus x squared, but we're going between 0 and 2 since that's the chunk that's above the x-axis. So we're going from 0 to 2. And then I'll throw my dx on the end. Now, the first thing we need to do is find the antiderivative of this function, so my capital F of x function. In here, with this 4, its antiderivative is going to be 4x. And then with this minus x squared, I'm going to throw minus. Now, this x has a power on it, so we do 1 over the power plus 1. And then we take our x and do the power plus 1. So we end up getting 4x minus x cubed over 3 as our antiderivative function. Now we're going from 2 to 0. So first I'm going to plug in 2. 4 times 2 minus 2 cubed over 3. So 4 times 2 is 8 minus 2 cubed is 8 over 3, so 8 thirds. We'll have to get common denominators in here in order to subtract those out. But we end up getting 16 thirds. Now I also need to plug in the 0. So 4 times 0 minus 0 cubed over 3. Well, 4 times 0 is 0. 0 cubed is 0, so 0 minus 0 is still 0. And then if we subtract those, 16 thirds minus 0, then this top portion has an area of 16 thirds. Now as we look at the portion that's below the x-axis, this is going to be the integral from 2 to 3 of that exact same function, 4 minus x squared dx. Its antiderivative is going to be the same, 4x minus x cubed over 3, but now we're going from 2 to 3. So first I'm going to plug in the 3. So we'll do 4 times 3 minus 3 cubed over 3. 4 times 3 is 12. 3 cubed is 27. 27 divided by 3 is 9. So 12 minus 9 is 3. Now, as we go to plug in the 2, we actually did that earlier and got this 16 thirds. So I'm going to do 3 minus 16 thirds, which ends up being negative 7 thirds. So this portion below the x-axis gives us negative 7 thirds for an area. Now, if we're looking at the net area, then what we're going to do is take the area above the x-axis, so that's 16 thirds, and then if we add on that area below the x-axis, so that was negative 7 thirds, so if we add those together, we end up getting 9 thirds, which is just 3. Now, if we want the total area, then actually what we're going to do is take the absolute value of each one of these. We don't care if it's positive or negative. We just want to put it all together to get the total area. So we're going to take the absolute value of that 16 thirds. Now that's already positive, so it's not going to change anything. But we're going to add on the absolute value of that negative 7 thirds. So that's going to turn that into a positive value. So then if we take 16 thirds plus 7 thirds, then we end up getting 23 thirds as our total area between the curve and our x-axis. Now this focuses on that total area. So if we want to find the total area analytically for a function y equals f of x between that graph and the x-axis over a specific interval from a to b, then what we're going to do is split up that a to b interval at the zeros of the function f. We're going to do each integral of f over the specified intervals, and then we're going to add the absolute values of those integrals together. That'll give us the total area versus getting the net area if we don't do those absolute values. Now we can also find the total area numerically on our calculators by using that function integrator to integrate the absolute value of our function over a given interval. Because doing the absolute value of the function would take any chunks that dip below the x-axis and rotate them upwards over the x-axis so that they end up giving us positive chunks of area. So here we're going to be numerically finding the area using that function integrator. So we're going to find the area of the region between the curve y equals x cosine of 2x and the x-axis over the interval from -3 to +3. Now this picture on the left is just the graph of this y equals x cosine of 2x. And we can see that there are some chunks that dip below the x-axis, but there are also some chunks above the x-axis. This picture on the right-hand side is the graph of the absolute value of this function. So we can see that all of those chunks that were below the x-axis got rotated up. So now instead of giving us negative areas there, now they're giving us positive areas. So in my calculator, I hit math and I go down to number 9. That's my function integrator. I want to go from -3 to +3, and my function is going to be the absolute value of x times the cosine of 2x, and then for my variable on the end, it's dx. I hit enter, and it tells me that the area is about 5.425. So to find the total area numerically using our calculator, if we're looking at the graph of some function y equals f of x, between that graph and the x-axis over the interval from a to b, so we want to take that function integrator in our calculator. We want to type in the absolute value of our function. We're integrating based on that x variable, and our lower limit is that a value, our upper limit is that b value. So then we don't have to worry about positive areas and negative areas because we typed in the absolute value of our function. The answer we get represents the total area. That's going to be it for this video. Thanks for watching.